Hello, welcome to 5.4. Guess what we're going to do? That's right. Let's do some factoring. Let's do some factoring. Let's do some factoring. That's right. We're going to factor and it's going to be amazing. Let's get into it. The two things I want you to remember from this class. Number one, fractions are not dangerous. You can do fractions. Number two, you should remember how to factor. Factoring is important. Factoring comes back over and over and over again. Hopefully you've figured out or you've made the connection from our last lesson that when finding zeros and multiplicity and all that stuff, how are we going to find those things? We're going to factor stuff. So let's do a quick review on factoring. So step number one, your first step in factoring is always find the greatest common factor and factor that out. In fact, I've still seen it in some of our quizzes in this class over and over again that we get stuck because we forget to factor that thing out, and it makes life so much easier. So if we look at these two things, they both have a couple of factors in common. Number one, they've got a 2 because they're both even. So you can factor a 2 out. And they also have an a squared. So they both have an a squared. So whenever you factor something out, it's kind of like dividing that number by the thing you pulled out. So if we were to think like, we divided by 2a squared, something like that, then what are we going to have left over? We are going to have 6a. Okay, so same thing over here. If we pretend like we divided by 2a squared is going to cancel out. 10 and 2, that's going to be 5. So we're going to have plus 5. So step one in factoring always is factor out the greatest common factor. So that also helps us out when we look at big messes of problems like that. So my brain goes into overload because I'm like, oh my gosh, there's so many numbers and letters and what's going on? It's okay. Just factor some stuff out. So if I look at these, 14 and 7, I like to start with my numbers first so we can pull a 7 out. Okay. So then that's going to be a 2. That's going to be a 1. So now I'm looking at letters. What letters do they have in common? So this one has a lot of M's. This one has 2 M's. So we can pull an M squared out. Again, a lot of N's, as in November. 2 N's. We're gonna pull an N squared out. So now we got to figure out what we have left over. So the 14 divided by 7 is 2. Remember from our quotient exponent rules, we take m to the 8th divided by m to the 2th or the 2nd. It's just going to be take 8 minus 2. So we're going to have m to the 6th. So then same thing, n to the 5th divided by n squared is going to be n cubed. 5 minus 2 is 3. And then this got factored out, this got factored out, that got factored out. So we're just going to have a 1 left over. So this is our factored form. So we've used difference of squares before in this class. We're going to continue using them. So step one, you need to recognize that you have a difference of 2 squares. So that's what that means, a squared minus b squared. And part of the way that you can do that is just by generally knowing your perfect squares. So if I were to list them off, so there's 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, and it goes on, but those are a lot less common. If you can just be generally familiar that if you see one of these numbers up here, that it is, in fact, a perfect square. And remember, I found those numbers. I took 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 15. So on and so forth. So So the important here, the important part is to recognize that you have a difference of squares. Once you recognize it, then it becomes a lot more simpler because you're just following a pattern or the rule. The rule is if you have a squared minus b squared, you can factor that into a plus b, a minus b. So when we go through some examples, it can sometimes be helpful to rewrite the problem in that a squared minus b squared form. So I'll do that just to really lay out which ones are a, which ones might be. You don't have to do this middle part when you're doing your own problems, but for some, it helps. So if I were to rewrite this as a number squared, I could rewrite that as 3x quantity squared, and then 49 is 7 times 7. So I can rewrite all of that as 7y squared. So when I rewrite it like that, it's very clear that my a is going to be my 3x, my b is going to be my 7y. And so then my answer, we just follow this pattern up here, is just going to be 3x plus 7y, 3x minus 7y. Done. It's factored. So if we move on to number 4, step 1. Okay, we know we're in a difference of squares section. 2 is not a difference of squares. So what we can do is we can factor that 2 out. So this is even, that's even, and hopefully you remember that 1 is a perfect square. I don't know what 72 divided by 2 is off the top of my head, but you know, I have a suspicion that it might be something convenient. So 72 divided by 2 is 36. So when we pull that 2 out, we're going to have 36 c to the 4th minus 1. So then I can rewrite that as in my difference of square thing as 2, don't lose the 2. 36 c to the 4th, don't let the c to the 4th, you know, kind of mess you up. You can just rewrite it as 6c squared on the inside, squared on the outside. So this will make that c4 right there. So we don't have to worry about that. And then we could say minus 1 squared. And again, it's very clear which ones are a, which ones are b. So our final factored form is 2, don't lose the 2, 6c squared plus 1, 6c squared minus 1. Factored. When we look at number 5, again, step 1 of factoring, no matter what, is pull out the greatest common factor. And here we are going to have a 7 and a 28. 28 divided by 7 is 4, so that's going to make our lives a lot easier when we do difference of squares. So we're going to pull a 7 out. Looks like they both have an m. Oops, put my parentheses in the wrong place. And looks like they both have one n. So that's all we can pull out. So what do we have left over? Inside the parentheses, in fact, I'm going to make them square brackets just so we can see it better. We're going to have 1m to the 6th minus 4, the m is gone, and one of the n's are gone, n squared. So from there, that is a difference of squares. We can see this one and that one, they're both squared terms. So we're not going to lose the mn. And since I'm running low on space, I'm just going to go straight into using our formula. So it's going to be m cubed minus 2n. I don't want squared brackets anymore. Oh, whatever. It's fine. and then m cubed plus 2n. There's an extra set of square brackets in there that don't do anything, but whatever. There you go. That's your factored form. So then if we look at number 6, same thing. Hey, look, they both have a 10 and a w in common. So always get that stuff out of the way before you go down the rabbit hole of trying to factor stuff, because it is part of factoring. So we pull the 10w out. We got w to the 4th minus 1. 1 is a perfect square, so we're good to go. So here we are going to do, using our pattern, 10w, w squared minus 1, w squared plus 1. So they throw a curveball at you in this one, because look at this guy. Is this a perfect squared minus a perfect squared? How do we factor that? That's right. It is a difference of squares again. So we're not losing anything, so make sure you rewrite everything that you need to bring down. So we're going to have w minus 1, w plus 1, w squared plus 1. And this is your final factored form. Okay, just like we have a pattern or a rule for difference of squares, we also have a pattern and rule for a sum of cubes. So if you see a cubed plus a cubed, then there is a rule for that. So again, it's good to know some of your cubes. So things like 1 is a perfect everything, 8, 27, and so on and so forth. The way I would look at this is I would look for variables that have a cube. So if you've got a cubed plus something else, that's going to trigger in my brain that, oh, there might be like a pattern that I need to check for here. This is not something that I would have you memorize, at least not in this class. If you want to go on to, I don't know, major in math, you might have to memorize this, but not here. You do still need to be able to recognize that, oh, this might be a sum of cubes. Oh, this might be a sum of cubes that I need to figure something out about. Maybe I should look into it. So that's kind of what I need you to be able to do, is to recognize that there are these rules and to be able to use them if you have access to those rules, which you will. So the rule is, if you have a sum of cubes, a cubed plus b cubed, that equals a plus b times a squared minus ab plus b squared. So this is just a pattern. It's a rule that all you got to do is to be able to plug stuff in the right place, and then you're going to be good to go. So for example, here we have an x cubed plus 27. 27 is one of our perfect cubes, so we can rewrite this as x cubed plus 3 cubed. 3 times 3 is 9, times 3 is 27. So then we're just going to plug it into this side of the equation, and we will be in business. So we've got x plus 3. That's the first part. Then we're going to have x squared minus 3x, a times b, plus b squared, which is 9. So then the reality is that there's a distinct possibility that this could be factorable. Let me see if it is or not. So in this case, it's not, but this is something that you'll always need to check to see if whether this is factorable or not. Because down the line, it wouldn't surprise me if we have a multi-step factoring problem. Okay, so number 8, I think, is a great example of, how do I recognize that this is a sum of cubes without having all of the perfect cubes memorized? So I look at this and I see a cubed, a variable cubed, plus and I see another variable cubed, and I see a number that I don't personally recognize as a perfect cube, but I see two other cubes, and they're added together, so I have a very high suspicion that 216 might be a perfect cube. So you can use your calculator to figure this out. Let's see here. Oh, it doesn't have an actual cubed root button, but you can go to math and let's see here, where is it? Oh, yeah, so math, and then go down to number 4 is the cubed root. You can't see that, whatever. And then you can just enter in 216, and it's going to tell me that that is an even number 6. So again, I can rewrite this as m cubed plus 6n cubed. So that's how you can recognize it. Once you get this far, plug and chug. So I'm looking at my rule up here, and I've got m plus 6n, that's my a plus b, times a squared is going to be m squared, minus a times b, 6mn, plus n squared, plus b squared, my b is 6n, so that's going to be 36n squared. And again, double check to see if this is factorable. In this case, it is not, but be aware of that. Okay, so we're at 9 now. I intentionally left our rule on the screen so that we can see that, we can reference it. Wow, 504. Ugh. So number 1, I do see a cubed, so I'm thinking sum of cubes, and it's in the sum of cubes section. I see 4, and 4 is not a sum of cube. However, 4 is divisible by 500. So step 1 in factoring, always pull out the greatest common factor. So we're going to pull a 4 out. 500 divided by 4 is going to be 125 a cubed plus 1. Let's see here. The cubed root of 125 is 5. So now with that knowledge, I can start plugging stuff in. We've got a sum of cubes. Our a is going to be 5a, and our b is going to be 1. So here we go. So we've got our 4 on the outside, and then we've got a plus b, 5a plus b, times a squared, 25a squared, minus ab, minus 5a times 1, okay, great, plus 1 squared, plus b squared, b in this case is 1, 1 squared is just 1. Last but not least, for our sum of cubes, again, this is one of those problems where it's like, ugh, I don't even know where to start. Always start with pulling out the greatest common factor, and then it might start to make sense after that. So, 24 is divisible by 3. 375 is also divisible by 3. So we can pull a 3 out. They both have a C, and they both have a D. So we're going to pull all of that out. Let's bring this down a little bit. Okay, so then what do we have left over? We got 24 divided by 3. I know that's easy to do, but sometimes I just need help. So, let's see, we pulled one C out, so we've got C cubed. Look, there's our cube. Our D is out, so that's gone. Plus 375 divided by 3 is 125. And then we pulled a C out and a D, so we're going to have D cubed. So that 125 is like 5 cubed. So our A is going to be 2c equals a, and then our b is going to be 5d equals b. So then from there, you just plug stuff in. So our answer is going to be 2c plus 5d. And I'm going to bring this over because we got to bring this stuff down. So we can't forget about that. 3cd. And then our rest of it is a squared. So 2c squared is 4c squared minus a times b. So that's going to be 5 times 2 is 10cd. And then plus b squared, which is 5d, so 25d squared. And that's it. So from there, you probably could, oh, no, you couldn't. I was looking at all of these values, seeing if we could pull out another like 2, but this is a non-number. So nope, we're factored, so we're good to go. All right, we've got one more rule to talk about, and that is the difference of cubes. So we've got difference of squares. Note, we do not have a sum of squares. So if you see 2 squares added together, that's not a good rule. We have a sum of cubes. That's what we just talked about. And now we have a difference of cubes. So it works the exact same way as both of our other rules. So we have a rule where it says, let's see here, where are we at? A cubed minus b cubed. And that is going to equal a minus b, a squared plus ab plus b squared. So your signs change a little bit, but it's still going to look very similar. So it's going to work the exact same way. We see a perfect cube, we see a perfect cube, and this time it's a difference. So we have a rule for that. We're just going to plug and chug. Our a equals x, our b equals 1. So then we're going to have x minus 1. A squared is going to be x squared plus x times 1, a times b is just going to be x plus b squared is 1. And there you go. That's factored. So 12's got some numbers involved. That's okay. I see the 125, and I know that that's a perfect cube because we've done some other problems with that number. It keeps popping up. 216 I'm less familiar with, so I'm just going to do a quick cubed root of 216, and that is going to be 6. So we have our 2 cubed roots. Our a is going to be equal to 6k, and our b is going to be equal to 5. And then here we go. So a minus b, 6k minus 5. A squared is going to be 6 times 6 is 36. K squared plus a times b. So 6k times 5 is 30. Plus b squared, which is 5 squared, which is 25. So there you go. So if we look straight into 13, again, I'm seeing 4, and I go, that's not a perfect cube. But 4 can go into 32, which means 8 times, which means we can factor that 4 out. So now we're dealing with a 4, 1 minus 8h cubed. 1 is a perfect square. 8 is a perfect square. 2 times 2 is 4 times 2 is 8. So our pattern holds, our rule holds, we can use it. So our a is going to be equal to 1. Our b is going to be equal to 8, not 8. 2h, and here we go. So our answer is going to be 4 times a minus b, 1 minus 2h, times a squared, which is just 1 squared, which is just 1, plus a times b, which is 2h times 1, which is just 2h. So to finish up, we've got our a squared plus our a times b, which is 2h times 1, and then b squared is just going to be 4h squared. So there you go, it's factored. And last but not least, if we're looking at 14, we've got that 2, which I don't like that 2. That 2 is not a perfect cube, but I still see a cubed and a cubed, so we can make that work. We're going to pull that 2 out. So now we've got x cubed minus 54 divided by 2, 27 y cubed, and that's going to be 3 cubed. So our a is going to equal x, our b is going to equal 3y, and here we go. A minus b, x minus 3y, a squared, x squared, plus a times b, 3xy, plus b squared, 9y squared. So once you get the hang of it, it's not terrible, but it is challenging to keep all of these different rules kind of separated. But let's keep factoring. So factoring trinomials is the same way we've been factoring trinomials, just these are, maybe a little bit more challenging because, well, we're a little bit better at it now. So might as well expand our brain. So remember, we've got an n to the fourth and an n squared. You can just kind of think of this as, like x squared, and this would be an x, but we would set x equal to n squared, and we can sub that back in later. I can kind of do this part in my head. I've gotten used to it. I don't know if that's something that you guys want to do. That's going to be kind of up to you. But we are looking for 2 multiples of 24 that subtract together to give us positive 2. So here I am, 24 divided by 2 is 12, not anywhere close. 24 divided by 4 is 6. 6 minus 4 is 2. So here we go. So we've got n squared plus 6, n squared minus 4. So that would give us, so that would be our factored form. We done yet? If you said no, good job. So this part right here hopefully triggered a few red flags. This is a difference of squares. So the difference of squares is the one that I do have memorized. But so we're going to have n squared plus 6. We're going to use our difference of squares. Remember, that's a minus b times a plus b. So then we're going to have n minus 4, n plus 4, n minus 2, and n plus 2. Now it is factored. So if we look at 16, it's the same, not the same process, but step 1 of factoring, I see a W, and a W, so that triggers my alarm bells to go, hey, pull that W out first and then start factoring. So we are going to pull that W out first, plus W minus 20. And now that actually looks a little bit more like what we're used to. 2 multiples of negative 20 that subtract together to give us positive W. So we're going to have W, let's see here, 20 divided by 4 is 5, which will give us the 1, and so we're going to have w plus 5, w minus 4, and don't forget your w out in the front. And that is factored. More practice with trinomials. Here we go. I see an A, an A, and an A. And I also see a 2, an even number, and an even number. So let's factor that stuff out before we get too deep into the weeds. And so we're going to have a 2A on the outside. So we'll have A squared plus whatever 38 divided by 2 is, 19A. And 68 divided by 2 is 34. So now 34, we're looking for two multiples. That's going to give us 19. So 34 divided by 2 is 17. 17, 18, 19. Okay, so we're good to go. Writing my 2A out front, we're going to have A plus 2, A plus 17. And it's factored. So looking at 18, always start off. I've got X and X and X. Let's pull that stuff out and see what we're dealing with. So we're going to have X to the 4th minus 24X squared. 24X squared minus 25, no X. Okay? So again, this can be kind of confusing because it's an X squared and an X fourth and an X squared, but you can kind of just sub in a different variable in for that and treat it like an X and an X squared or like a Y and a Y squared, and you can still factor it. So we're going to have our X on the outside. 25 subtract together to give negative 24. So we're going to have X minus 25, X plus 1, and voila. No, just kidding. So this is going to be an X squared and an X squared, which then turns this into a difference of squares. So now we're going to have X minus 5, X plus 5, and we're going to have X squared plus 1. There you go. I almost tricked you. So number 19, we've got that 3 in front right there. That's kind of annoying. And you can't pull a 3 out of either of those two, so it's there to stay. So to deal with that, remember, we're going to take this 3. We're going to slip it into that number right there. So now we're going to have X to the 4th plus 14X squared minus 15. Okay, so then we'll factor that. We've got X squared. I'm not going to make that same mistake again. Plus 15 X squared minus 1. I'm glad they make the trinomials here a little bit easier to factor. But we have that 5, or we slipped that 3 into the 5, so now we got to pull that out. So divided by 3, divided by 3. So our new answer is going to be X squared plus 5, X squared, or 3X squared minus 1. So I'm wondering if that is a difference of squares. It is not a difference of squares because this is not really a perfect square. So it's factored. We're good. One more trinomial to go. 9 can't come out of any of those. So we're going to take that 9, put it into the 4. My brain hurts, so I'm just going to do 9 times 4. So now we've got m to the 4th minus 12m squared plus 36. 36 is 6 times 6, and then 6 plus 6 is going to be 12. So we're going to have m minus 6, m minus 6. But we brought the 9 in, so now we got to bring the 9 out. Okay. So then this is going to cancel to 1/3. This is going to cancel to 1/3 as well. So then we're going to have 3m minus 1. No, minus 2. I knew something was wrong. Minus 2. And then 3m minus 2. That one wasn't terrible, right? Okay, a lot of this has been reviewed up until now. So if you have sped the video up, slow down right here. Pay attention. So we're going to be factoring a polynomial with 4 terms. We haven't done that yet. So this is brand new. So we're going to factor something with 4 terms. So if you see 4 terms in a polynomial and you're supposed to factor it, this is the method you're going to use, and it's called grouping. So we're going to group the first 2 items together and the second 2 numbers together. Then we're going to factor those out, and we're going to hopefully try to find something similar that we can then factor that out, and we'll end up having something that is a little bit more manageable after that. So we're going to group those 2 together. We're going to group those 2 together. So what that's going to look like, we're going to pull the greatest common factor out for each of them. So we're going to have an x squared out from the first part. So x plus 1. And we'll do the second part in green. So then we're going to pull a negative 4 out from the green part. So we're going to have minus 4x plus 1. Notice our signs did change because we pulled a negative sign out. So then from there, so that's what we mean factor the greatest common out from each group. So then from there, we can factor the common binomial. So what that's talking about is this part right here. There's an x plus 1 and an x plus 1. So we're essentially just going to factor that out as well using the same mechanics, just a little bit bigger, I guess. So we're going to pull the x plus 1 out. So that means that we have x plus 1. And then what do we have left over? Goes in parentheses. So we've got x squared minus 4. So that would be factored normally. But what is that? So yeah, that's going to be a difference of squares. Generally, you should always, if you have an x squared or anything higher than an x in your factored form, you should double check for things like difference of squares. Well, that would be the only thing you can check for a squared. But anyway, so we're going to finish factoring that out. We got x plus 1. That's coming from right there. So then we're going to have x minus 2, x plus 2. And there we go. We factored an item with 4 terms. So if you look at this one, you can kind of tell. So we have x cubed, x squared, and so on and so forth. So if we multiply all of these x's together, we are going to get that x cubed. And then, quick kind of check. We've got negative 2 times positive 2 would give us that negative 4. And then the rest of the stuff would end up canceling out into that part right there. So factor by grouping. Anytime you see 4 numbers in a polynomial, factor by grouping. Okay, let's try some examples. So if we're looking at 21, you can just group the first 2 together and then group the second 2 together. And again, we're trying to make them have a similar factor in common. So with my blue group, we're going to pull out an x squared. So we've got x minus 1. And then our green group, we're going to pull out a 9, and then we're going to have x minus 1. So now we've got the x minus 1 in common, so that's what we're going to factor out. So now we're going to have x minus 1, and then what we have left over is x squared plus 9. Hopefully by now you've gotten in the habit of going, ew, an x squared, that probably shouldn't be my answer. In this case, it should, because this is a plus, so it's not a difference of squares or it factorable in any way, shape, or form. And so we are done. It is factored. Okay, so if we're looking at 22, same thing. We're going to go with our first group and our second group. So our first group, we're going to pull out a k squared, k plus 5. And then our second group, we're actually going to pull out a -1. So notice how the signs are different. So we want to pull out that -1 or just negative sign so that we get a positive k plus 5. So now these two things match. We can factor that out. So here we go. We're going to factor out a k plus 5. Then what we have left over is k squared minus 1 because we took the entire k plus 5. Now, hopefully, again, you have an alarm bell in your head going, ew, a squared in my answer. That's wrong. You would be correct because we've got a variable squared minus a perfect squared. So we do have difference of squares. So let's finish this up. Plus 5, k plus 1, k minus 1. And now it is totally factored. So our last two problems, we are going to, again, solve by grouping. So we're going to group these guys together. Pull a v squared out. I don't see anything else that can come out. So we've got v squared. So we've got 4v minus 5. So then here, our second group, our minus sign is in the wrong spot and the numbers don't match. So we need to pull out a negative sign, and that's going to switch these two signs, which will help us out. And then we need that 16 to be a 4, so I think if we pull out a 4, right? Yeah, so we're going to pull out a -4. So then that 16 is going to turn to a positive 4v. Then that 20, that positive 20 is going to turn into a -5. And then you'll notice that these now match. So now we can factor out the 4v minus 5, 4v minus 5. And then what do we have left over? We have v squared minus 4. Which, oh no, there's a squared here left over. This is a difference of squares. So let's finish it up. 4v minus 5, v minus 2, v plus 2. And there you go, fully factored. Last but not least, let's do our last problem right here. We're going to group these two together, and see where we go. So our first two have an x to the 4th included together and a 2. So we're going to pull a 2x to the 4th out. So let's see here. That means that we're going to have an x minus 9, and that's it. Okay, no problems. So that means over here we're going to have to pull a 7 out. Don't have to pull a negative sign, so that's nice. That's going to be x minus 9. These two match. We're in good shape. So what do we have left over? We got an x minus 9 that we're factoring out. Then we're going to have a 2x to the 4th plus 7. Whew, x to the 4th. So I see that. I'm thinking, is there a difference of squares? Not a minus sign, so don't worry about that. Sum of cubes? Is there any way that could work? I don't think so. So yes, this is our factored form, but I want you to get into the habit of always double checking to make sure that it is fully factored by the end of it. So that is our factoring review. I'm going to let you know that during class, you will have time to fill this sheet out, but this sheet, I'm not going to specifically tell you how to fill it out. This is going to be your notes sheet. This sheet right here, I will let you use on a quiz and test to help you with the factoring part. But you still have to fill it out and make it your cheat sheet. So I'll have printed copies for you, hopefully. If not, then I'll print some copies off for you, and then you can use this sheet on a test or a quiz. So there you go, factoring. Remember, 2 things that you should always remember from this class. Fractions are not terrible. You can deal with fractions, and don't forget how to factor.